Welcome Algebra 2 students. Today we're going to look at something called inverse variation. We are looking at the first part of Chapter 8. Our learning target today is to recognize and use inverse variation. Now you'll notice here we have both direct variation and inverse or indirect variation. We've talked about direct variation in previous courses, but we are going to review it here today. In both cases, notice that there is a k in your equation. That k is called the constant of variation, and it can never equal 0. That would just create a 0 for the whole thing. So for direct variation, we have y equals k times x. It is a linear graph. Think of y equals mx plus b, that type of thing. So y equals kx would just be a linear graph. Its y-intercept would be 0, and your k value would really just represent your slope of your line. In this case, both of your values increase together, or one decreases at a constant rate. For example, if your slope is positive, we have a line that's moving up. So as our x increases, our y also increases. If we have a negative sloping line, as our x increases, our y value decreases, but at a constant rate. So that makes it a direct variation problem. For an inverse variation, when the two quantities vary inversely, as one quantity increases, the other decreases proportionally. So we have y equals k divided by x. That is our new equation to be working with today. So this is a proportional thing, right? As as x increases, y has to decrease proportionally. So if you think about it, if k is a constant value and you increase your x, what you're dividing by, then your y is going to have to get smaller. All right, so in order to determine from a table of values whether you have a direct or inverse variation, the first thing you want to do is just try those points in your two equations, your two basic formats, and see which of them gets you a consistent k value. And then once we know what that k value is, we can write out our equation. So for this first one, we have our x value is 0.2, our y value is 8. And notice that as x is increasing, all right, from the top of our table to the bottom of our table, our x value is getting bigger. So is our y value. So this makes us think it's probably a direct variation type equation. So let's start out with direct variation, y equals k times x, and let's just see if we can get a constant k value. If we tried to solve this formula here for k, we would have to divide the x over. So we're looking really to see, does our y value divided by our x value always come out to be the same? So let's take 8 divided by 0.2. That's the same as 80 divided by 2, which would be 40. If we take our second example, our y value is 20, we're dividing it by a half. That's going to get us 40 as well. Our third example, we have 40, we're dividing by 1, which is obviously 40. And our last one, we're taking 60 divided by 1.5, and that is also 40. So because we're getting a consistent answer out for k, that is our value for k. So k would be 40. It is a direct variation, which means it has to fit that equation y equals k times x. So we now can plug in our k value of 40 and say that y equals 40x is the equation that fits that table of values. All right, looking at our second example here, again, notice our x's are increasing as we move down, but our y values are decreasing. Now, that could be a negative sloping line, so it could be direct variation with a negative slope or negative k value. But let's check to see if it's an inverse. Is it proportional? Okay, we are not going down by a consistent amount, but it's hard to tell because our x values aren't going up by a consistent amount either. So let's double check. If we think this might be inverse, okay, we're going to start out with y equals k divided by x. To solve for k, we would have to multiply the x over. So if this is inverse variation, then our x times y always has to come out to be a constant. So let's try. 2 times 15 would give us 30. 4 times 7.5, we get 28 plus another 2, that is also 30. 10 times 3 would be 30, and 15 times 2 would be 30. So it does fit an inverse variation. In this case, our k value was 30. So our formula would be y equals 30 divided by x. All right, so go ahead and pause the video. I want you to try to figure out if you can tell which type of variation we have in each of these tables. And once you figure out the type, find your constant of variation, that k value, and then write your equation. Go ahead and turn the video back on when you think you're ready. All right, let's check to see how you did. Looking at our first example, we have either y equals k times x or y equals k divided by x, direct and inverse. So let's check to see if we get a constant with our direct variation. So let's start with dividing our x over. Y divided by x should give us a constant. If we take our y values, 1.5 divided by negative 1, we get negative 1.5. If we take negative 1.5 divided by positive 1, we get negative 1.5. If we take negative 3 divided by 2, we get negative 1.5. So we are getting a constant. That means this one is direct, not inverse. Direct variation, y equals negative 1.5 times x. All right, with our second one, again, we can try direct and see if it works. To get our constant, we would take y divided by x. So negative 10 divided by 40 would be negative 1/4. If we take negative 5 divided by 20, we get negative 1/4. If we take 2.5 divided by negative 10, that's the same as 25 divided by negative 100. Again, negative 1/4. So this one is also a direct variation. Y equals, and you can put that in as a decimal, so negative 0.25x, or you could write y equals negative 1x divided by 4. Either one would be fine. All right, our next example, it says your math class has decided to pick up litter each weekend in a local park. Each week there's approximately the same amount of litter. The table shows the number of students who worked each of the first 4 weeks of the project and the time needed for the pickup. So if we have 10 students working, it took us 24 minutes to clean up the park. If we have 12 students working, it took us 20 minutes. 15 students only took 16 minutes. If we had 32 students, it only took 7.5 minutes, which makes sense. The more students, the less time it's going to take. All right, so determine if this is direct or inverse variation, and then what equation models it. So again, if it is direct, it has to fit y equals k times x. If it is inverse, it has to fit y equals k divided by x. Okay, now, I always take those equations and I solve for k to check to see if we can get a constant. So let's start with our y value. 24 divided by 10 is 2.4. If we take 20 divided by 12, we get 1.6 repeating. So we're not getting a constant here. That means it's not direct. Okay, let's try our inverse. To solve y equals k divided by x for k, we would have to multiply our x over. So we want to check, does x times y give us a constant? So 10 times 24 would be 240. 12 times 20 is also 240. 16 times 15 is also 240. And 32 times 7.5 is also 240. So we are getting a constant of 240. So our equation then would be y equals 240 divided by x. And that is an inverse variation. So now figure out how many students should there be to complete the project in at most 30 minutes. Go ahead and pause the video and see what you can set up for this. All right, now, hopefully you paid attention to, we want at most 30 minutes. So remember our time here was our y coordinate. We used x and y. We could have used the t here and the n. So time was 240 divided by the number of students. But we want our time to be at most 30 minutes. That means total time less than or equal to 30 minutes. So 240 divided by n has to be less than or equal to 30 minutes. To solve this, we're going to multiply n to the other side. And then we would have to divide out our 30. And 240 divided by 30 would be 8. So we need our number of students to be greater than or equal to 8. So at least 8 students would be needed. All right, so for our last type of question here, it says we're going to write equations for a variation. Step 1, set up the structure. So if it is direct, we want to use y equals k times x. If it is inverse, we want to use y equals k divided by x. Once we know which of our basic formats we're using, we're going to plug in the given values to figure out our constant, and then we can use that constant to write our equation. So what's different about these questions is instead of a whole table of values, we're just given one ordered pair, one x and y combination, but we're told what kind of variation it is. So the first sentence here, suppose x and y vary inversely. So they're telling me that it has to fit this y equals k divided by x format. Okay? And then we're told that when x is 4, y has to be 12. So if we plug those in, put a 4 in for x, we should get a 12 for y. So to solve for k now, we're just going to multiply 4 to both sides. We end up with k equaling 48. And so once we know our k value, we can write our equation. So we set up our structure, we plugged our values in to find k. Now we're going to put k back into our actual equation. And we're going to say y equals 48 divided by x. That is the equation that models this situation. Once we have that equation, we can then answer this type. So what would y have to be if x is 10? So we can plug a 10 in there. 48 divided by 10, we would get y being 4.8. So there's kind of several steps to these questions. We start out with the basic format. We plug in our x and y values to figure out our k. We then use k in our equation. And once we have that equation, we can use it to find other values for y. All right, next one, suppose x and y vary inversely. So again, y equals k divided by x. This time when x is 2, our y value is negative 5. So negative 5 is equal to k divided by 2. We're going to multiply 2 to both sides, and we end up with k being negative 10. So now I'm going to write the equation. What function models this variation? The answer would be y equals negative 10 divided by x. Then we can answer what is y when x is 4 by plugging a 4 in. Negative 10 divided by 4 would be negative 2.5. All right. Our last one here says suppose x and y vary directly. So notice now it's not an inverse variation, it's a direct variation. Direct variation means y has to equal our constant times x. When x is negative 4, so k times negative 4, we're supposed to get a y value of negative 8. To solve for k, we would have to divide out the negative 4. And negative 8 divided by negative 4 would just be 2. So we have a constant of 2. My equation then, the function that models this variation, would be y equals 2x. And I can then use that equation to figure out what is y when x is 12. And we would get an answer of 24. All right. So in summary, we're talking about direct and inverse variation. For direct variation, y equals k times x. In order to figure out what that constant is, though, we would divide the x over. So y divided by x equals k. That's what you would use to figure out your constant. Okay? If it is inverse variation, we start out with y equals k, our constant, divided by x. And in order to find our constant, we'd have to multiply x to the other side. All right, so to find k, we use that version. But when we write our equation, we use the top one. Okay? All right, let me know if you have any questions.